Product price scraping and analysis. What is product price scraping? Why web scraping matters for data mining. Real-world uses of product price data. Lesson goal: learn basic scraping and analysis for product prices. Running the cell now. Why learn product price scraping? It allows you to collect real-world price data quickly. Businesses track competitors using scraped prices. Data scientists use pricing data to find trends. Skills you learn here help in many areas of analytics. Running the cell now. Our first step is to silence Python warnings. This keeps our notebook easy to read and avoids distraction. Always suppress warnings for a cleaner notebook. Import warnings. Warnings.filter warnings. Ignore. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This initial setup code doesn't produce visible output but is crucial for clean, reproducible analysis. Suppressing warnings keeps your notebook tidy, while setting a random seed ensures consistent, repeatable results when generating or sampling data. These practices help maintain professionalism and reliability as you start scraping and analyzing product price data. Warnings are messages about possible code issues. They can clutter tutorials, so we turn them off for now. Data setup. Let us grab a sample set of product prices from a test e-commerce site. The site is made for practice scraping and is safe. We load and preview 5 products including their prices. Running the cell now. In this cell we will fetch and show 5 products with prices from a simple shop demo site. This is a safe and public website created for web scraping testing. Data setup, product price scraping and analysis. Import requests. From BS for import Beautiful Soup. Headers equals user agent are Mozilla 5.0. URL equals https://webscraper.io/test-sites/e-commerce/static/computers/laptops. HTML equals requests.get, URL, headers equals headers.text. Soup equals Beautiful Soup, HTML, HTML.parser. Items equals d.select_1.title. .get_text, strip equals true, d.select_1.price.get_text, strip equals true, for d in soup.select.thumbnail. Print items, 5. Running the cell now. This output shows the first 5 product names and their prices scraped from the e-commerce site, confirming the code successfully extracted the relevant data. Notice each tuple contains a product title and a price string, which sets the foundation for further analysis like cleaning and converting prices for calculations. This preview ensures our web scraping and parsing approach is correct before moving forward. Requests helps us fetch web page data from the internet using code. Beautiful Soup lets us search inside HTML easily. The headers trick makes us look like a normal web browser. We pick out product names and their prices. We print just the first 5 products for a quick look. If you find this helpful, please like and subscribe to our channel for more beginner Python tutorials. Turning product and price data into a pandas data frame makes analyzing easier. A data frame is like a super-powered Excel table. Let us organize those products into a table for analysis. Import pandas as PD. df equals PD data frame items. Column sad smiley product, price. Print df.shape. df.head. Running the cell now. The output shows our data frame contains 6 rows and 2 columns, confirming we have 6 products with their corresponding prices. Notice the columns product and price clearly organize the data for easier analysis, aligning with our goal to structure the scraped information. This setup prepares us for further data manipulation and insights. We import pandas, a super popular data tool for Python. We build a data frame table using our scraped data. Print df.shape tells us rows and columns count. df.head shows the first 5 rows so we see what is loaded. Data cleaning, prices. Our prices are strings with currency symbols. To analyze, we must convert prices to numbers. We will remove symbols and change type. Running the cell now. Cleaning up the price column is an important early step. Right now, the price still includes the $sign. #remove currency symbols from price column. df price equals df price dot street replace $.astype float. df.head. Running the cell now. Here we see the first 5 rows of the price column after removing the $signs and converting the values to floats. Notice that the prices are now numeric, allowing for mathematical operations and analysis. This step is crucial for preparing our data to accurately compare and summarize product prices. We use street replace to delete the $sign from all price values. Astype float turns those text prices into real numbers we can use in math. Clean data allows us to do totals and averages easily. Missing data is very common when scraping websites. Let us count blank or missing values in each column. #check for missing data, very common in real-world scraping. Print df.isnl.sum. Running the cell now. This output shows there are no missing values in the product or price columns, which means our price data is complete and ready for cleaning. This is an important step before removing currency symbols and converting prices to numeric types, ensuring we don't inadvertently introduce errors with missing data. ISNL finds any missing or blank entries. SUM adds them up by column so we see problems fast. Simple stats analysis. Now that prices are numbers, we can ask questions. How many products do we have? What is the most and least expensive product? What is the average price? Running the cell now. With clean price numbers, we can quickly see overall insights. #basic descriptive stats on product prices. Print number of items, df.shape, 0. Print minute price, df price.minute. Print max price, df price.max. Print mean price, round, df price.mean, 2. Running the cell now. Here, the code summarizes key statistics about product prices. We have 6 products in total, with prices ranging from $306.99 to $1,311.99. The average price is $756.16, which helps us understand the typical cost before diving deeper into the data. This step confirms the data is ready for more detailed analysis by giving us a quick overview. We print how many products we scraped. Minute price and max price tell us our price range. The mean price shows the typical cost in this set. Let us find out which products are the cheapest and the most expensive. Find the name of the cheapest and most expensive products. Cheapest equals df.loc, df price.idexmin. Expensive equals df.loc, df price.idsmax. Print cheapest product, cheapest price. Print most expensive product, expensive price. Running the cell now. This output highlights the cheapest and most expensive products in the dataset, using their names and prices. It shows how we can identify specific items by applying functions like idexmin and idsmax on the price column, connecting directly to our goal of exploring simple stats to better understand product pricing. Idexmin finds the row with the lowest price. idsmax finds the row, or product, that costs the most. We print the product name and price for both. Visualizing product prices. A simple chart can make price comparison easier. Let us plot all prices as a bar chart. Running the cell now. Visualizations turn numbers into pictures. Bar charts help us spot which product is cheapest or most expensive instantly. Plot a bar chart of product prices. Import matplotlib.pyplot as plt. plt.figure, figsize sad smiley 10.5. plt.bar, df, product, df, price. plt.xticks, rotation equals 45, r equals right, font size equals 8. plt.illabel, price, USD. plt.title, product price comparison. plt.tight_layout. plt.show. Running the cell now. This bar chart visually compares the prices of each product, making it easy to spot which items are more or less expensive at a glance. Notice the clear labels and rotated product names that improve readability, highlighting the intent to simplify price comparison through straightforward visualization. Matplotlib is a popular Python charting package. We make our figure wide so names fit. Product names are tilted for readability. This bar chart makes it easy to compare all prices at a glance. Sorting helps us answer questions like, well, what are the 3 cheapest laptops? Sort products by price from lowest to highest. df_sorted equals df.sort_values, price. df_sorted.reset_index, drop equals true, in place equals true. df_sorted.head. Running the cell now. Here we sorted the products by price from lowest to highest to prepare for a clearer visual comparison. Notice how the cheapest products, like the Aspire E1-510 at $306.99, appear at the top of the list, setting a natural order for the bar chart. This sorting step helps highlight price differences more effectively in the upcoming visualization. Sort_values arranges products from lowest price to highest price. Reset_index makes the new data frame easy to read. df_sorted.head shows the 5 cheapest products right away. Filtering lets us focus on a specific type of product. Here we look just at laptops with prices above $1,000. Filtering show only products above $1,000. Expensive_products equals df, price, greater than 1,000. Expensive_products. Running the cell now. Here, we've filtered the data to display only products priced above $1,000, highlighting the higher-end options in our catalog. Notice that the output shows just 2 products meeting this criterion, which we can now visualize to compare their prices clearly. This step sets the stage for our bar chart by focusing on a manageable subset of premium products. Filtering means choosing rows that meet a special rule. This is useful for quickly finding premium or budget items. Mini exercise, your turn. Try filtering for products below $400. What happens if you try $1,500? Can you find the product with a price closest to the average? Running the cell now. Finding the item closest to the average helps you spot what a typical product costs. Challenge, find the product closest to the average price. Average_price equals df, price.mean. Closest equals df.ilog, df, price, average_price.abs.idexmin. Print, product closest to average, closest, product, closest, price. Running the cell now. This output shows the product with a price nearest to the average price of all products, which is the ProBook at $739.99. Notice how the code calculates the average price, then finds the product with the smallest difference from this average, helping you understand how to identify central values in your data. This reinforces the lesson's focus on filtering and comparing prices effectively. ABS finds the difference between each price and the average. Idexmin locates the smallest difference. We print the product name that is closest to the average price. What you learned. How to scrape product and price data safely. Simple cleaning to make data usable. Basic analysis and charts for insights. You can build on these steps for more advanced scraping. Like and subscribe for more beginner Python lessons. Running the cell now. Let us make the analysis interactive. With input, the script can ask you for a price minimum. Hash optional, let the user enter a price filter using input. Price_cutoff equals float, input, show products above what price? Enter a number. Filtered equals df, price_cutoff. Print, filtered. Running the cell now. Here, the code filters the product data to show only those with prices above a user-defined cutoff, demonstrated by selecting laptops priced higher than the input threshold. Notice how the filtered table retains the original structure but displays fewer rows, focusing the analysis on more expensive items. This step highlights how interactive filtering can make scraped data more targeted and insightful for decision-making. Here we ask you to enter a number as the minimum price. The script returns all products above that price. This is a basic way to let users explore different scenarios.